Here I have nitroglycerin, and it's going to be decomposed, which we know as an explosive releases a lot of energy quickly. If I put a little bit of energy in this, initially break the bonds that are present, I will release a lot more when the new, more stable bonds form. So I start with C3H5N3O9. That's the formula for nitroglycerin. And the reaction is already balanced, so in general, again, on the exam, you would have to probably balance any reaction that's there. So then that produces nitrogen, carbon dioxide, water, and oxygen. Then in part A it says, what is the maximum amount of oxygen in grams that can be obtained from 200 grams of nitroglycerin? Maximum amount. Theoretical yield. If I had 200 grams of nitroglycerin in it, were theoretically to all react, how much oxygen could I get? Right, so that's exactly the type of calculation we just looked at. If I want to know how many grams of oxygen I can make from a limited amount of one of my reactants, in this case there is only one reactant, so that has to be my limiting reactant. I'll just call this Ng for nitroglycerin, so I don't have to keep writing the formula and taking up space. If I have information about one substance, I want information about a different substance, I always have to convert to moles because the relationship between the quantities of those two substances is a mole relationship. So I'll have to get the molar mass for nitroglycerin. So 3 carbons plus 5 hydrogens plus 3 nitrogens plus 9 oxygens gives me 227.09 grams of nitroglycerin per mole of nitroglycerin. So the grams cancel. The reason I've done that is so that I can convert the moles of one substance into moles of the other substance we want information about. And I need to get to moles first because the relationship between two substances is a mole relationship. So 4 nitroglycerins will only produce 1 oxygen. So I could say 4 molecules of nitroglycerin will produce 1 molecule of oxygen, or I could say 4 moles of nitroglycerin will produce 1 mole of oxygen. I can't say 4 grams of nitroglycerin will produce 4 grams of oxygen because the balance reaction is a numerical ratio. It's not a mass ratio or a volume ratio. It's a numerical ratio. It tells me the relationship between numbers of things. So now I've got moles and I want grams, so I would cancel the oxygen and moles and try to get grams of oxygen. So that relationship would be from the periodic table, so I would add 2 oxygens together, 32.00 grams per mole. For O2, I've got the units I want, so I multiply 200 times 32 divided by 227.09 divided by 4, and I get 7.3 sig figs I've got here, so 7.05 grams of O2. So that's part A. Part B, calculate the percent yield if the amount of oxygen generated is found to be 6.55 grams. So percent yield is actual over theoretical times 100. This formula is on the formula sheet, although really it shouldn't need to be because it's the same way you calculate any percent. The amount you got divided by the total amount possible times 100. So the amount we're getting, it tells us in the question, if we actually did the reaction, is 6.55 grams. The maximum possible is the theoretical yield, 7.05 grams. And so if I multiply that by 100, I'll get it as a percentage, And so I have 92.9. Well, I have to round that 96, so I round the 9 up, so I get 93.0%. So what does that 93.0% mean? Right. So I produced 93% of what I could have possibly gotten. So where's the other 7%? What happened? Two possible answers. So one possible answer is maybe it didn't react. Maybe I still have a very small amount of nitroglycerin that didn't react. And so that's why I didn't get as much oxygen as I predicted. Another possible answer, maybe when the nitroglycerin reacted, it went through a different reaction than this one. I have one balanced reaction for one possible rearrangement of the electrons and atoms in nitroglycerin. That doesn't mean that's the only possible reaction. A lot of times there are side reactions that occur. And instead of all of the nitroglycerin undergoing this process to produce these things as well as oxygen, maybe there's some other reaction that the nitroglycerin underwent, and I got something different for some side reaction. That's also a possibility. Another possibility is I failed to collect all of the oxygen that was actually produced. Maybe all of the nitroglycerin did react, but some of the oxygen escaped and I didn't collect it all, and when I got my actual measured amount of oxygen, some of it I was unable to collect. That happens a lot too. So there are a few reasons why the percent yield you might measure will be less than 100%. So you should be aware of those reasons as well, in case I ask you about them. What about a scenario where my measured yield or my actual yield is greater than the theoretical? Is that possible? Is it possible to actually collect, in this example, more than 7.05 grams of oxygen? It shouldn't be possible, right? Unless I incorrectly measured the starting amount of nitroglycerin and I actually had more than I thought, that starting amount of nitroglycerin is limiting how much oxygen I can make. It's limiting me to 7.05 grams. So if I do this reaction in the lab, I get my gas that was produced, I measure its mass, and I find that its mass is more than 7.05 grams. What does that suggest? So one possibility is I started with more nitroglycerin than I thought I did, and I measured that incorrectly. So when I calculated theoretical yield, obviously that wasn't right. Another possibility is the product that I have collected in the end and measured the mass of might have impurities in it, or byproducts or side products in it. Right? So in a case like this, I'm not just producing one product, I'm producing CO2 and nitrogen gas, and I've got water, which would probably come off as a vapor if it were at a high temperature. So if I'm trying to collect just the oxygen and see how it compares the collected amount with the theoretical maximum amount, if the collected product also has some other products or substances in it, that will add to the mass. And if I'm not aware that my collected product has impurities in it, and I assume it's all 100% oxygen, but maybe really that oxygen has some nitrogen or CO2 in with it, then yeah, the mass is going to be higher. So if you do a reaction, and this goes for the reaction you're doing in the next lab experiment, if you do a reaction, you collect your product, somehow you find that the mass of your product is greater than it could possibly be, even if the reaction went 100%, it probably suggests that you haven't removed all the byproducts and you haven't completely isolated your product from the impurities that are present. And those presence of those impurities are adding to the mass and making it seem like you've actually formed more product than you have. So another step or some methodology to remove the impurities is probably what you need to do to make sure that the master measuring of your product is just that one product, so that it really needs to be below 100% yield. You can't actually have more than 100% yield if you've actually effectively purified your product.